How do you test your designs today? Most of the time, you design the way you've always done it, and then build a prototype and test it out. And then something fails, and then you rinse and repeat. Now, there are fantastic tools available to you with SOLIDWORKS Simulation for design validation that can save you countless hours of testing and a ton of money in the process. But although it's a perfect fit for most applications, what if you're dealing with situations that require a simulation at the next level? This is where SIMULIA, running on the 3DEXPERIENCE platform, can revolutionize the way you simulate your product. So let's take some time today to talk SIMULIA and the vast capability it can bring to your organization using the power of the platform. We can begin with a team meeting using the 3D Lean team role on the platform. We can have all the information and collaborative capabilities at our fingertips, with the ability to easily prepare for the meeting beforehand with guided agendas. First, I can make sure all attendees are present for the meeting, and then we can start with our agenda, move to the CAD data review, and finally create any action items we may need to keep everyone on track. Starting with our meeting agenda, we can see that CAD updates have been completed, and we need to review and determine the simulation studies required to test our product in a digital environment. We can review the design with the 3D Play app directly inside 3D Lean and collaborate and mark up to brainstorm our next steps. After some discussion, it's decided that we need to start with an FEA analysis to validate our design. We can create and assign action items as a team and get going on our studies.
Based on our team meeting, we need to validate our design with an impact capacity study. Obtaining the impact capacity of the ROV is critical in the design process and can be challenging to simulate. Let's see how easily this can be modeled with SIMULIA solutions on the platform. Our goal is to estimate the impact performance for the ROV frame as it hits a wall. With the help of a connector, storing data on the platform is done with a click of a button. It is stored in recognizable formats, making it easy to perform design changes in the future. Now that our model is saved, let's go ahead and open the Structural Mechanics Engineer role to begin the setup. We will model the ROV to impact the wall with a specified velocity. Simulation apps on the platform share a common interface, such as tree structures and user-guided assistance. This shortens the learning curve for platform users, making it quick and easy to get the job done. Let's start the setup by creating an analysis, in this case, structural. Finite element models, or FEMs, can be created using meshing methods such as automatic or based on saved rules. This lets users create their own templates for modeling, avoiding redundancy. With the FEM created, let's define the explicit dynamic step, which leverages abacus-driven technology to perform the impact analysis. Step size increments can be automatically identified, and mass scaling can be used to accelerate the simulation if needed. We'll keep most of them at defaults. Simulations are just as accurate as the material. With section definitions, we not only define them with a simple search, but also include its behavior. With many behaviors available, we can simulate just about any structural analysis. Let's finish it off by defining the rigid body behavior of the wall. Leveraging connectors can help model simple components such as bolts and springs if present. This defines how loads are transferred without having to include the component, saving on simulation time. A game changer to this solution is the ability to define contact properties such as tangential and normal behavior and automatically identify all surfaces that come in contact. This removes the pain of defining explicitly the surfaces that touch, which saves a lot of time and reduces potential errors on the study setup. Since the wall will not displace, let's fix it with a clamp condition. This is done simply by picking the wall and activating it. While we're at it, let's also define our loads. In this case, it's an initial velocity on the ROV frame. Meshing can be painful if limited tools are available. Fortunately, we have a library of element types, making it easy to perform and optimize it. Sizes can be estimated based on part dimensions, providing an excellent starting point to the process. With offered sectioning and quality analysis tools, it's easy to check if the mesh is good enough for the study. We're almost done with our setup. Let's perform the automatic model, scenario, and simulation checks to ensure that there are no issues present currently or foreseeable in the future when the job is submitted. Looks like our simulation is good for a run. Let's go ahead and submit it. We have flexibility in the submissions process, whether it's on the cloud with credits or locally. Leveraging high-performance machines gives us control in how we want to submit our study and how soon we need those results. Monitoring the evolution of the simulation can be critical, and the structural mechanics engineer role offers an interactive solution. With real-time plots and diagnostic files generated on the fly, we can even see the simulation progress and fine-tune subsequent runs if needed. Again, a lot of transparency and flexibility. Our simulation is done. Let's check the results. We can leverage XY history plots to not only judge energy balance and simulation quality, but also the evolution of physical quantities with time. Rendered animations can be generated easily to judge performance. As with other simulation solutions, contour plots can be probed and sectioned to get better design insight. With the 3DEXPERIENCE platform and its powerful simulation capabilities, a connected and easy-to-use solution is available without having to interface between standalone tools, making simulations an enjoyable experience. With results available on the platform, it's easy to share and collaborate our findings with other stakeholders and post them to our community for discussion and review.
Now that the initial study has been validated and posted to our swim community, it's easy for the team to review and discuss our next steps. After some back and forth on the community, it's decided that we also want to be able to run a fluid simulation as well, to test our design in an active water environment. So we can move our FEA action item to finished and create an additional item for our flow study. Now, because our lean team board is updated in real time, Vishnu can see that he has a new action item assigned to him and get going as soon as he can.
To characterize the performance of the vehicle underwater, let's see how we can virtually set up our ROV study by leveraging the platform simulation solutions. The connector can be used to save our model and transition to the platform simulation environment, all within SolidWorks. We are tasked with running an external flow simulation to help estimate the propulsion performance and maneuverability of the vehicle. Let's see how we can do this with the Fluid Dynamics Engineer role. With an easy-to-use tree structure and a user-guided assistant, setting up flow simulations can be completed in a short amount of time with minimal effort. This lets designers and engineers hit the ground running on their projects. We begin the setup process by defining our fluid region. In this case, it's the space around the ROV. This is done with the help of quick modeling tools in the role. I don't even need to switch to a CAD application. The overall process is made easy with visual feedback to indicate the flow domain direction and surface selections to track forces. With context-centric tools, such as phase propagation, selecting multiple entities doesn't have to be manual. Finally, existing material data can be leveraged for defining the fluid material, in this case, water. A library of commercially available turbulence models can be used to perform a variety of simulations. Turbulence coefficients can be characterized to match data available, increasing the study's fidelity. We'll stick to the defaults. With auto under relaxation, we can leverage a SIMULIA patented technology to accelerate convergence. Boundary conditions are critical to the setup of flow studies, and the Fluid Dynamics Engineer role offers a portfolio of options. We will model a velocity inlet and pressure outlet condition traditional to such simulations. We can also specify turbulence coefficients such as turbulence intensity and viscosity ratio. We will go for a slip wall condition to model the flow domain boundaries. The default no slip is automatically applied on the ROV surface, subtracting the need for manual phase picking. Moving and rotating walls can also be specified if needed. Tracking data to judge the simulation's accuracy is critical, and the role provides a myriad of context-specific physical quantities to extract results for determining performance and convergence. We will monitor data on the inlet, outlet, and the external faces of the ROV, such as mass flow, gauge pressure, and force development. With FMK's superior meshing tools, we can create a variety of body-fitted meshes and leverage advanced capabilities to even accelerate the process. The very desirable hex-dominant meshes are chosen for this study to reduce mesh element count while improving overall mesh quality. Meshes can be viewed interactively with the Sections tool, making it easy for visual inspection. Tools are readily available to estimate mesh quality to help with fine-tuning. Our setup is complete, and we have one more step before running it. Let's check the model to see if there are any errors. The role automatically identifies any incorrect or missing elements, making it a pain-free experience. Simulations can be submitted locally or on the cloud using high-performance machines. This makes it easy to leverage resources on a need basis without really investing in machines upfront. Now that our simulation is completed, let's check our results. With history plots, we can track physical quantities such as forces and check if they've converged. Residuals can also be monitored on the fly or after the simulation, making it easy to judge convergence. Contour plots can be created with superior rendering capabilities and probe to get better design insights and decide next steps. Finally, streamlines can be generated with a click of a button to help understand the flow around the vehicle. With the Fluid Dynamics Engineer role, we've observed how easy and painless our setup process for a flow simulation can be. Leveraging the connector, we're able to bring in data and transition to the platform without flipping between tools. Once on the platform, a user-guided assistant helps to set up simulation in a few minutes and post-process those results. This can also be shared with other team members to accelerate product development and get the design finalized in a shorter time.
With the ease of use and robust capability of Fluid Dynamics Engineer on the platform, we were able to get a flow study for our product set up and run fast. If we go back to our lean board, we can mark that as complete to update the team. We can take a quick look at our problem tracking as well and make sure we are up to date. Now, although we can mark most of these issues as complete, we do see that it's been brought to our attention that we need to test for electrical interferences for our onboard IoT devices. Now, we've seen some amazing capability utilizing the SIMULIA Structural Mechanics Engineer and Structural Performance Engineer to tackle complex FEA setups with ease, as well as the power and performance of Fluid Dynamics Engineer on the platform. But we do have one more thing to show you today. With the latest update to the 3DEXPERIENCE platform, we now have the capability for electromechanical simulation utilizing the Electromagnetics Engineer role and the power of best-in-class CST Studio Suite technology. Let's take a sneak peek at this exciting new capability for the platform.
In today's world, where digitalization, communication, and electrification are critical industry drivers for sustainable innovation, electromagnetic phenomena have to be understood and controlled as never before. To be successful, designers and engineers are looking for assessing electromagnetic effects early in the design cycle. The Electromagnetics Engineer role introduces a new paradigm to easily access the most comprehensive portfolio of electromagnetic simulation, SIMULIA CST Studio Suite, inside the 3DEXPERIENCE platform. With this role, users will be able to install CST Studio Suite directly from 3DEXPERIENCE Cloud for easy deployment and up-to-date release cycle, test SOLIDWORKS designs saved on 3DEXPERIENCE Cloud with efficient workflows, and break silos between design and simulation. Associativity is ensured for intuitive what-if scenarios. Empower engineers with state-of-the-art virtual testing tools for antenna, microwave, and electronic device design to optimize performance and reduce the electromagnetic compatibility risk. And present KPIs and results with easy-to-understand dashboards to managers, customers, and decision-makers by means of a web-based app, even on mobile devices. Best of all, our unique solution is model-based as opposed to file-based, which provides seamless collaboration between other engineers and departments on the cloud. 3DEXPERIENCE Cloud provides access to high-performance computing hardware for small and large problems. It provides a flexible and scalable solution for tackling immediate computing demands and for minimizing hardware costs. SIMULIA's Electromagnetics Engineer role facilitates efficient and smooth end-to-end processes, from conceptualization to design, simulation, engineering, and finally delivery to market. With Dassault Systèmes Solutions, you can streamline your design and simulation process today to produce the electronic devices of tomorrow.
With products getting more and more complex and demanding, we need to be able to tackle any situation that comes our way. SIMULIA on the platform will elevate your validation capabilities while keeping the whole team connected and collaborative. Whether you are a seasoned simulation professional or are looking at taking a dive into predicting your product performance in an accurate and an intuitive way, look no further than the power of the platform. As always, if you'd like to learn more about SIMULIA and the 3DEXPERIENCE platform, get in touch with Javelin today and let's start collaborating.